All right, so this video is going to encompass a few different types of equations, specifically 3 different styles. The first, solving polynomial equations by factoring. The second, solving radical equations. And then the third, solving absolute value equations. So let's go ahead and get started. In order to solve polynomial equations by factoring, the first thing that we want to do is kind of sort of just treat it like it's a quadratic equation and put it in that form. You want everything on one side of the equation with it set equal to 0. So jumping right into example A, the first thing I'm going to do is move that 9x over. I'm going to move that 27 over as well so that it's no longer on the right-hand side. So my equation would look like 4x cubed minus 12x squared minus 9x plus 27 is equal to 0. So think of it as putting it in quadratic form before getting started. Once it's in proper form, we want to go ahead and factor it. Now, depending on the problem we're given is obviously going to depend on the style of factoring that we do. Here we're looking at a 4-term problem. And 4 terms typically means that we're going to be using factoring by grouping. That's exactly what we're going to be using here. Factor by grouping, you want to chop your problem in half, and you want to factor out a GCF from each one of those groupings. Looking at my front grouping here, 4 and 12 has a 4 in common, so I'm going to pull that out. And x cubed and x squared has an x squared in common. My GCF for this first grouping only is 4x squared. If we factor that out to the front, again, we're going to pull that out to the front, divide it out of that group to see what's going to be left in our parentheses. When we divide, 4 over 4 cancels to a 1. X cubed over x squared is just an x. Minus 12 over 4 is a 3. And x squared over x squared cancels out to a 1. Looking at our SPAC grouping over here, when we factor out a GCF from the back grouping, we treat it as if it is its own problem, which means if the leading coefficient is negative, we do need to pull out that negative with our GCF. Otherwise, taking a look at the problem, 9 and 27 has a 9 in common, and it looks like that's it. We have an x here, but not here. So negative 9 is our GCF for that back grouping. Factor it out to the front, divide it out from your problem to see what you're left with. Negative over negative cancels. 9 over 9 cancels out to a 1. So we drop down that 1x, which again is just an x. Different signs here gives you negative, and 27 over 9 is a 3. Once we're done with that step in factor by grouping, our next step is to factor out the GCF one more time. If you notice, our problem now has 2 terms in it, and we have an x minus 3 in common for each one. So we are actually going to pull out that x minus 3 as a common factor. We're pulling it out to the front, which also means we are dividing it out here. When we divide that out, x minus 3 cancels with x minus 3, leaving us with that 4x squared. X minus 3 cancels with x minus 3, leaving us with that minus 9. Wrap some parentheses around it, set that equal to 0, and we are ready for our next step. We are done with the factoring portion, right? We are completely done with that portion, so we can move on to our solving portion here. In order to solve this, again, we solve this using the zero factor property. Once it's factored here, we can split those factors up, set them each equal to 0, and solve. So let's see. I'm going to put x minus 3 over here, and we had x minus 3. Let's set that equal to 0 and solve. We also had 4x squared minus 9. Set that equal to 0 and solve. Take your 2 factors, split them up, set them each equal to 0 and solve. To get our first solution over here, just add that 3 to the other side, and we get that x is equal to 3 for our first solution. For our second solution, we are going to add that 9 to the other side, giving us 4x squared is equal to 9. Divide out that 4 there, giving us x squared is equal to 9/4. And then take the square root of each side. On the left side, square root and square cancels, leaving us with x. On the right-hand side, instead of taking the square root of 9/4, we're going to take the square root of the numerator and the square root of the denominator. Anytime we take square roots, we are going to tack in our plus or minus, and the square root of a 9 is a 3. Square root of 4 is a 2. So our first solution is x equals 3, followed by our second and third solutions here, plus or minus a 3/2. Let's immediately move on to our next example here. Taking a look at our next example, we are also solving this one by using factoring, which means step 1, move everything over to one side of the equation so that it is set equal to 0, so we can begin factoring. Now in this example, we have two terms, but what we're going to do here is we're just going to factor out a GCF. Now GCF with a 3 and an 81 is a 3. GCF with our x's would be an x here. Again, we have x to the 4th, x, always take the smaller of the two. So 3x is our GCF. If we factor out 3x, let's divide and see what we're left with. 3 cancels with 3. X to the 4th over x, subtract those exponents. 4 minus 1 leaves us with x cubed. Minus 81 over 3 is a 27, and x over x cancels. We have it in factored form now, so we're going to split these factors up, set them equal to 0, and solve, which means we have 3x is equal to 0. We also have x cubed minus 27 is equal to 0. Now, in order to solve these two equations here, dividing out the 3, we are left with x is equal to 0 as our first solution. Now, taking a look at what we're left with here, this is a cubic equation here, and this is actually the difference of cubes. I went ahead and added the difference of cubes formula right over here. We are going to have to factor this using the difference of cubes, which means we need to assign our a and our b. That is going to be then just plugged into this formula. Remember, a is what times what times what gives us x cubed. Well, x times x times x is x cubed, so a is going to be an x. B is going to be a 3, since 3 times 3 times 3 is 27. So we need to go ahead and throw that in here. The difference of cubes says to take a minus b. A is an x, minus is part of the formula, b is 3. Our trinomial that we have here says to take a squared, which will give us x squared, plus a times b. X times 3, 3 times x is a 3x, plus b squared. Well, if we take 3 and we square it, we get a 9. So these are actually the follow-up factors that we're then going to have to solve here. So if we split these up, we have x minus 3 is equal to 0. And we have x squared plus 3x plus 9 is equal to 0. Add the 3 to the other side, and we have our second solution, x is equal to 3. This equation over here, it looks like we are going to have to plug this into the quadratic formula, which means a is 1, b is 3, c is 9. Again, this does not factor. And typically, if a quadratic equation does not factor, I'm just going to go straight to the quadratic formula and throw it in, which means negative b plus or minus the square root of b squared minus 4ac all over 2a, giving us negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 1 times 9 is 36. Over 2 times 1 is a 2. Just subtracting here, negative 3 plus or minus the square root of, well, 9 minus 36 is equal to a negative 27 over 2. I'm going to go ahead and break up the square root of negative 27 over here just to simplify that before throwing that back in there. Well, 27 is 9 times 3. And then I'm going to pull out that negative 1 here. Okay, so that's how we're going to break up the square root of negative 27. Now, the square root of 9 we can do. The square root of 9 is a 3. The square root of negative 1 is an I. Square root of 3 cannot be simplified, so we drop that down. So square root of negative 27 is 3i square root of 3. I'm going to go ahead and plug that in over here. Negative 3 plus or minus 3i square root of 3 over 2. This would represent our third and our fourth solution for this one. The second style of equation we're going to be focusing on is solving radical equations. Step 1 in solving radical equations says to isolate the radical. Get it as isolated as possible. So if we have just one radical like we do here in example C, get that radical completely by itself on one side. So I'm going to go ahead and start this by adding 6 to the other side, giving us the square root of 2x plus 15 is equal to x plus 6. Step 2. Now, the step 2 is based off of the fact that we're just using regular square roots in these radical equations. The opposite of a square root is taking the square. So that's why the next step here says square each side. Now, I do want you to note, though, if this were, let's just say that this were like the cube root of x plus 1 is equal to something. If you're dealing with a cube root, you would cube each side. Fourth root, you're going to, take a fourth root, you're going to raise each one to the fourth power. Since square roots are the typical opposite of a square root is taking the square, which is why our next step here is to square each side. When we square the left-hand side, square root and square cancels out, leaving us with 2x plus 15. On the right-hand side, we actually need to square that out. We need to do x plus 6 times x plus 6. Now, you can distribute it and combine like terms, or I always like to try and focus on mental math way of squaring a binomial. Mental math way of squaring a binomial, it tells you to take the first thing here and square that. X times x is x squared. Take the two things here, multiply them together. X times 6, 6 times x is a 6x. Double that to get 12x. Square the second thing. 6 times 6 is a 36. How do you distribute it over here? X times x, x times 6, 6 times x, 6 times 6. Notice that you would be left with the same thing. So you can definitely distribute in FOIL if that's your thing. I like to try and focus on mental math way of squaring it, going from here straight to here. Anyways, once we square each side, as long as we do not have a radical left in our problem, all right, if we have a radical left in our problem, we're going to go back up and we're going to simplify and square each side again. That doesn't apply here. We don't have a radical left in our problem, which means we want to solve the remaining equation. Notice the remaining equation here is a quadratic equation. So noticing that this is a quadratic equation, one of the easiest ways to solve a quadratic equation is to solve it by factoring. So in order to do that, first things first, let's get everything moved over to one side of the equation so that it is in proper quadratic form so that we can get it ready for factoring here. So I'm just taking everything on the left, moving it to the right-hand side. So this is a 21 here. So when we subtract the 2x to the other side, subtract the 15 to the other side, we're left with this quadratic equation. Solve the remaining quadratic equation. Now I am going to attempt to factor it. So let's see. X squared tells us x times x. Factors that multiply to 21 that add or subtract to get 10 is going to be our 3 times our 7. Everything is positive here, so everything's positive in our factors, which brings us to zero factor property. Once you have it factored, split those factors up, set them each equal to 0, and solve. So x is a -3, or x is a -7 for our two solutions here. For our next example, since I am running out of room here, I'm going to go ahead and just do that on the back of this page here. So this is what our next example looks like. So step 1 in solving a radical equation tells us to isolate the radical as much as possible. Notice that we do have two radicals in this example here. So what I'm going to do is I'm going to take this one here and I'm going to add it to the other side. That way I have one radical on one side, one radical on the other side. That's about as isolated as I'm going to be able to get this problem. Next step, let's go ahead and square each side. So when we're squaring the left side, square root and square cancels, we can drop down the x plus 5. This right-hand side, I'm going to write out the multiplication over here. We are taking 2 plus the square root of x minus 3 times 2 plus the square root of x minus 3. Again, keep in mind, that's what we're doing when we're squaring this. Let's go ahead and multiply this. 2 times 2 is 4. 2 times the square root of x minus 3 is 2 square roots of x minus 3. Now distribute the square root of x minus 3. The square root of x minus 3 times 2 is 2 square roots of x minus 3. Our last multiplication, square root of x minus 3 times square root of x minus 3 is x minus 3. We're multiplying it times itself, which means we're squaring it. All right, this is really just square root of x minus 3 squared, what we're doing. Square root, square cancels, leaving us with the x minus 3 there. Let's clean this up just a tiny bit before throwing it back into our problem here. I have a 4 minus a 3, which is a 1. I have this x that I'm going to go ahead and drop down. 2 square roots of x minus 3 plus 2 square roots of x minus 3. These are like terms. 2 of them plus 2 of them. I now have 4 of them. So this is what it looks like when I simplify that multiplication. I'm going to go ahead and throw that in right over here. Now, because we still have a radical left in the problem, we kind of need to repeat this process here. Isolate the radical and square each side. So I do need to get this radical by itself. So I'm going to subtract that 1 to the left-hand side. I'm also going to subtract the x to the left-hand side. Now that means on the left-hand side, x minus x is going to disappear, leaving me with 5 minus 1, which is a 4. I subtracted these, I moved these over, so all we have is a 4 square root of x minus 3. Now, just because these numbers actually happen to be the same, I can go ahead and divide that out. 4 divided by 4 is a 1. 4 divided by 4 is a 1, right? So I can cancel that out. Now that the radical is isolated, we can square each side. 1 times 1 is a 1. Squaring the right-hand side, square root cancels out with square, leaving us with an x minus 3. Add that 3 to the other side, and we get that x is equal to 4. Third technique we're talking about here is solving absolute value equations. Now, the thing about absolute value is that if I take the absolute value of 3 and I take the absolute value of negative 3, we get the same thing. Keep in mind the definition of absolute value is the distance a number is from 0 on a number line. So if we look at a number line here, right, and we look at the examples I'm talking about, if I look at negative 3, it's 1, 2, 3 away. If I look at positive 3, it's 1, 2, 3 away. They're both 3 away from 0, so I get the same answer. Absolute value bars make whatever's inside them positive, right? If it was positive, it stays positive. If it was negative, it's going to go positive. So when we're solving these equations, we actually have no way of really knowing, was this positive or negative to begin with? Because we're going to end up taking the absolute value and making it positive, right? But we don't know if it was initially supposed to be positive or negative. And what I'm trying to get by that is when it comes to solving absolute value equations, we create 2 equations, one for the positive, one for the negative. So step 1 in solving absolute value equations, get the absolute value portion completely by itself. Example E is already set up that way for you. Otherwise, drop down the example, ignoring the absolute value bars. 2x minus 1 is equal to 5. Put a set of equal signs on the left-hand side. Write the same number you have on the right-hand side, just different signs. If this says positive 5, I want negative 5 over here. If this says 14, I'll be using negative 14. That type of thing, right? So what we've done is we've created a double equation here. We're going to be solving the middle side. Our ends over here are going to be our solutions. So solve the middle portion here. Get x by itself. We're getting rid of the minus 1. The only difference in solving this type of equation than a regular equation is we have 1, 2, 3 sections now, right? A left, a middle, a right. What you do to one side, you do to all 3 sides. So to get the middle section solved for x, I'm going to add 1, making sure I do it to all 3 sides. I get a negative 4 on the left-hand side. I'm going to drop down that 2x, and on the right-hand side, I get a 6. Divide out that 2, and we are left with a negative 2 on the left, x in the middle, and then 3 on the right-hand side. Those are our two solutions. X equals negative 2, x also equals a 3. Those represent the two solutions to this equation. So let's go ahead and jump directly into example F. Isolate the absolute value bars, which means we need to get rid of that 2 there in front. So divide by it. 2 divided by 2 cancels. Let's drop down the absolute value of 3x minus 2 is now equal to a 7. Once the absolute value portion is isolated, we can rewrite our equation. Drop it down, ignoring your absolute value bars. Here we have a 7 on the right, so we're going to put a negative 7 on the left-hand side. Solve this equation. And again, we're always solving the middle section. Add 2 on all three sides. We get a negative 5 on the left. Drop down 3x in the middle, and we get a 9 on the right. Divide out that 3, and we get a negative 5/3 on the left, x in the middle, and 3 there. So x is equal to negative 5/3. X is also equal to 3. Represents your two different solutions there. Last example. Let's isolate this absolute value by subtracting 6 on each side. That gets our absolute value by itself on the left-hand side. Set equal to a negative 4. Now, I want you to pause for just a second here. It's really, really easy to get caught up in these problems and just to continue working here. Right, the absolute value of x plus 1 is equal to negative 4. Let's drop this down. Set it equal to a positive 4 on this side. But before we do that, going back up to our initial here, taking a look at this equation, this is saying that the absolute value of x plus 1 is equal to negative 4. I want you to think about this for a second. It doesn't matter what I plug in for x. Let's say I plug in negative 1,000. Negative 1,000 plus 1 is negative 999. If I take the absolute value of 999, that's going to be a positive number. And it said that this is going to equal negative 4. Anything that we plug into here and add 1 to it, is essentially going to go positive. What I'm trying to get at is these absolute value bars are going to make anything inside here positive. And we're saying that this is going to equal a negative number. It's not possible. Absolute value makes everything positive. So it doesn't even matter what x plus 1 is. Whatever's going to go inside here will be positive because of these bars. So if it's initially set equal to a negative number here from the beginning, this is what a no solution problem looks like for this. There is no solution because this is not possible to do.